welcome back to Tutoring by Albina. In today's unit, I'm going to be doing the Introduction to Algebra 2. In this unit, we have, of course, a complex fractions unit. As you can see, we're going to be reviewing factoring. We have a factor flowchart, very helpful. A lot of this stuff, if you are in Algebra 2, you would know the introduction of the review and things of that sort. But we have multiplying and dividing rational expressions, subtracting and adding them, and solving them. So we do have quite a lot in this unit, but it's nothing we can't handle coming from Algebra 1. So we're going to start off by going over this very helpful flowchart. Okay, here I have a physical copy of the flowchart. So let's just go ahead and go over this. So, of course, this is for factoring. And we know what factoring is, right? It's when you're trying to reduce an expression by most of the time your GCF is what you start with. You look for the GCF, the greatest common factor. We know this. So this is kind of your flow chart, what you should be doing. These are all the steps you're going to need. Obviously, you're not going to use all of them all the time, but depending on your expression or your equation, these are the different types of factoring that you can do. So let's go over this. So first things first, you got to look for the greatest common factor, right? If I have 10x plus 5, 10x plus 5, what can I factor out of this? I can factor out a 5, right? So if I factor out a 5, that's going to give me 2x plus 1. That's what we call factoring. So that would be a greatest common factor. So once you have a greatest common factor, there's three big subsections that you're going to be looking for. A binomial, which we know would have two terms, right? Two of these, a and b. Trinomial, right? Three of these terms. And then four terms, which you can end up grouping like this. So let's start with binomial. So with binomial, you have a couple of different options here. You have the difference of two squares, which would be when you have two perfect squares, so you would end up subtracting them. And so the formula for this binomial, the difference of two squares, is a plus b times a minus b. And there's a method called foiling, but essentially it's first outside, inside last, right? So you have a squared minus b squared. Essentially the method every time is just going to have a plus b times a minus b. And that's how you're going to do that, difference of two squares. So if I had 4 squared minus 2 squared, and I wanted to factor this, I would just write it like this, right? A plus b and a minus b. So it'd be 4 plus 2 and 4 minus 2. Of course, that doesn't have an x variable in it, but that's just with numbers. That would be the basic idea. You're going to have a variable every time, of course. Then you have the sum of two cubes, okay? So cube, we know, is to the third power, not to the second, to the third. So let's say you had a cubed plus b cubed. Your formula for this is going to be a plus b times your a squared minus ab. Multiply those two, not the cubed. Remember, we're reducing. That's why it's a plus b in the first place. So ab plus b squared. And that's just going to be your formula every time. And that's when you're having a sum of two cubes, when you're adding these. Same thing for when you're subtracting them, except you just flip this to a negative and these to positive. So if you can see, there's a lot of patterns that happen within these formulas. And once you get those patterns down and just remember them and recognize them in the expressions, you'll be good to go. So that was binomials. So just remember that you just have to use these every time. And we'll see examples within the worksheets that I show. But that would be that. Next, moving on to trinomials. We have three different categories for trinomials. First up, we have perfect square trinomials. So for perfect square trinomials, this is an example here. 9x squared plus 24x plus 16 equals 3x plus 4 squared. There's a couple different ways that you can look at this, but down here, it's telling you that the square root of your first term times the square root of your third term is going to give you your middle term. So if we can check that too. Square root of 9 is 3 times square root of 16, which is 4, times 2 equals, indeed, that equals 24, which is our middle term right here. So you could even do that here if you wanted to break this apart. Another way you could do it is just by multiplying 3x plus 4 by 3x plus 4. Again, that's going to give you the answer to 3x plus 4 squared. And that's also going to give you this. That's what the answer would be. Now, don't make the mistake of when you see 3x plus 4 squared, do not write 3x plus 4 times 2. That is not the same thing, and you're going to get the wrong answer. Squaring is not the same thing as multiplying by 2. Moving on, we have trinomials, x squared plus bx plus c. So this is where m times n equals c, and m plus n equals b. So this is where you're finding pairs to essentially complete this factorization. So an example down here, x squared plus 5x plus 6 equals x plus 2 times x plus 3. So how did we do that? Well, we know once we multiply these numbers, the first term and the last term, that gives us a 6, but the middle number is 5. So what pairs of 6, what factors of 6 multiply to 6, of course, but then give us 5? Or when we add them, they give us 5, or when we subtract them, they give us 5. 6 and 1, that's 6. And 2 and 3, 2 times 3 equals 6, and 2 plus 3 also equals 5. So that's perfect. So now we found our pair, right? And we know from here that m plus n will equal b, which is this, our b term. So now we know this x squared has to distribute into an x and an x in the pair. There's no other option. So 1x will be in this pair, and 1x will be here. And then we just take the pair that we found that matches up with the middle term and multiplies to our last term. And we know it's going to be plus because there's no subtraction happening here. So it's going to be x plus 2 and x plus 3. And if you multiply this together, if you did the FOIL method, first outside, inside last, x times x is x squared, 2x plus 3x, if you were to multiply those, equals 5x, and 2 times 3 equals 6. That's the FOIL method. That's a way you can check your work. That's a way you can solve the problem. It's a very useful method. Again, down here, and x squared plus 5x minus 6, we have a subtraction now. You would know that one of them needs to be subtracting, so you have to figure out which one. So that's when you're going to use this first pair, 6 and 1, because there's going to be subtraction happening. So if we were to check this answer with foiling, first outside, inside last, we know x squared, okay, these x's, plus 6x, this, minus x, this multiplied by this, and then minus 6. So once we solve this out, we should be getting this original expression. So x squared plus 5x minus 6. And as we can see, it checks out. Next up, you just have your classic trial and error method. You guess and check, right? So find factors of the first term, a, right here, and factors of the third term, c, and guess and check. So example here, 6x squared minus 11x plus 3. So you're really just finding factors of these two terms. Factors of 3 would just be 3 and 1. So that's why we have a 3 and 1 here. There's no other option. And factors of 6. But remember, when you do the FOIL, you need to get 11 from those. Because as we see up here, m plus n needs to equal b. So this is our b. This middle term is our b. And this is our m. And this is our n. But of course, it's not just like this and this equals that. It's after you multiply everything out. So that would be your guess and check method. And I highly recommend you use this foiling method. That's how you're going to be able to check everything. Next up, we have our 4 terms and grouping. So both groups of 2 will have a greatest common factor that can be factored out. So it will turn into a greatest common factor by parentheses. This is your example down here. X squared plus xy plus xz plus yz. So once you factor this out, if we look at this expression here and we just split it into 2, this is a very easy method, and it's probably going to turn into your favorite method every time you can do it. What do this term and this term have in common? An x. So what can we factor out? An x. What do this term and this term have in common? A z. So we'll factor out a z. right? So here we're just simplifying it, just writing it in a different way, just so it looks more simple. That's the same thing. And like I said, once we factor out an x, we're going to write it like this. And once we factor out a z, we're going to write it like that. Now, if you notice, this is the exact same as what's written in these parentheses. They're the same. So that tells us we're just going to be multiplying this thing, that's just occurring once really, with this plus this. So that's why your final answer is going to be x plus y, okay, right here. We just took this. We have this in common, so it's basically its own greatest common factor. You just take it out of this whole equation. So you have x plus y, and then your remainder, which is x plus z. So that is how you get that answer, and that is grouping by 4 terms. So this sheet here, if you want to take a screenshot of this and use this as practice, this is just factoring. You know, it's just asking what you remember about factoring from Algebra 1. So I'm not going to go over this sheet, but we can keep scrolling down. And this is the answer key to that sheet. If you want to take a screenshot of this, this would be very helpful. And that would be that. So now this is the notes for this. Greatest common factor, taking it out. This is pretty simple. The greatest common factor of this and this, you just take it out, and that would be our simplified answer. And of course down here we would have the answers to those. So you can of course use your factor trees. 14 times 2 is giving us 28, and you can just keep going separating it like that, and that's just how you get your greatest common factors. Difference of squares. So again, the flow chart that I just went over has the formulas that you need to do this, and really once you know the formulas, it's just the same thing over and over again for this complex fractions unit. Now of course down here this is the box method, which we'll get into later, and this is the other formula. And so here is the simplifying rational expressions notes. So definition, what is a rational expression? So rational expression is an algebraic fraction whose numerator and denominator are polynomials, so they have multiple terms. And so the domain for this, which we will maybe get into later, way later, but all real numbers except for those which the denominator equals 0, undefined / error. So one thing to note about this is that you need to state your restrictions, right? We can never have the denominator as being 0, because that means it would be undefined, and that's not what we're looking for. So when you have a denominator, you need to state a restriction which would make your denominator 0. So down here you can see y cannot equal 0, because then everything would equal 0, and then it would be undefined. That's what your restriction is. So anytime in your denominator, you need to make sure you're stating your restriction. Here we have x minus 5, so we cannot have x be 5 or negative 5 here, because then in any case it would be 0, and we're just trying to make it never 0. We never want it to be 0. So anyway, here are the steps to solving this. So one, you want to factor both the numerator and the denominator if it's possible. If it's not possible, you just leave it, of course. State your restrictions, and then cancel any like factors, which means cancel any like terms. So here we have x plus 5, and at the bottom we have x plus 5, so we just cancel it out like that. Same thing here. Once we've factored it using your flowchart, this would be the trinomial one, x plus 3 and x plus 6. The bottom cannot be factored, but you have 2 common things here, so you can cancel them out. You're left with x plus 3 as your answer. And then for your restrictions, we know that the only thing that was ever in the denominator was this x plus 6. So what would make this 0? Negative 6. So that means x cannot be negative 6, because we are not wanting zeros. And then down here, these are similar problems. Here you have 6 minus 3x. You can take a greatest common factor out. There's nothing more complicated. So that would be a 3. And you're left with the 2x, 2 minus x on the inside. And then bottom, at the denominator, you can factor it like this. First, you have a greatest common factor, which would be the 2. So you take that out, and you're left with x squared minus 5x plus 6. And then you would go ahead and factor that into x minus 5 and x minus 2. And these would cancel out, and your restrictions would be stated there. And so the next part of these notes that we are going to do would be multiplying and dividing these rational expressions. So if you look down here, we have some review. Obviously this is just literally just doing it with fractions, but it's kind of to give that big idea. So when we're multiplying fractions, we just of course multiply right across. So the answer to this would be 6/35. and then at the end you would just simplify everything. Same thing here, multiply across. And then with division with fractions, we know we would use the keep, change, flip method. So we'd keep 6, turn this into multiplication, and then flip this for its reciprocal, which would be 8/3. So it'd be 6 times 8/3 would be the way to solve 6 divided by 3/8. We know this, we've been through that. So using that kind of big idea, there are some steps, obviously, to multiplying and dividing rational expressions such as these. So number 1, you're going to change division problems to multiplication by the reciprocal. That's just the keep, change, flip. Factor all numerators and denominators completely, so we're just breaking it down. And then you're going to state your restrictions, which you could honestly do at the beginning. Cancel any like factor, any numerator and denominator, so we're just crossing anything that crosses out. And we're multiplying across to get your final answer. And of course you can leave parentheses, and you don't need to distribute parentheses, just for our simplicity. Now, these are just the steps as it gives to you. There are different ways of tackling these problems if you're someone that doesn't need to factor, because you can just multiply 6 times 15 and you know what's going to cross out top and bottom, and that's a way to do it too. Your restrictions aren't going to change. It's just going to be D and A cannot equal 0. That's just a way to do it. But following these steps, let's just go ahead and do this first one. And of course, you need to review your factoring chart to be able to factor things like this over here on 2, which I'm sure you definitely have practice with now, or you will be getting used to that factor chart to do stuff like this. But anyway, let's go ahead and use our steps to solve number 1. So we don't need to change anything because it's not division, so we're just going to keep it like this. Factor all numerators and denominators completely. So we don't have to do that, but something we could do if we go down to the work section is we could just break this down for our own simplicity. So we know 6 is made up in 2 and 3, and 15 is made up of 3 and 5. And then, of course, those variables we just have a C there, a C here, and 2 D's here, because at the top you can see that this is D squared. And you can do the same thing for the bottom. Can't break down anything about 5, but there's a D. And 8 we know is really just 2 cubed, so that's a way to do that. Now the reason the work is being shown this way is to show, it's a method to be able to cross things out easier and simplify your fraction easier. You don't have to do this if obviously it's very simple enough for you to do that. But yeah, you really just want to turn this into one fraction. And so once that's simplified anyways, it would be 9c squared over 4a, and as I mentioned, the restrictions would be a and d cannot equal 0, as you see here. Now, just to make sure, the rule for exponents is that exponents don't necessarily tell you what to do, they tell you where to go, of course. So if you had a negative exponent, you're going to move that to the denominator. I don't think there's any negative exponents here, but that's just as a reference. Of course, you can subtract. If this was a c squared and this was a c, I could just subtract. We know those exponent rules with division, and with multiplication they would be adding here. And so that's that. So that's really it. As long as you know how to factor, this is just simple multiplication, but we can go ahead and do this one. 2x plus 8, that would factor, you have a greatest common factor of 2, so that would go into 2, and then x plus 4 in the parentheses. 4x, and we have to remember that this is division, so we are going to be doing the keep, change, flip. So this would turn to multiplication, and you would have this flipped. Now, an important thing to note, because we flipped it, we're going to need to have 2 sets of restrictions. We're going to need the restriction before we flipped it here for x, and the other x restriction, which would be after we flipped it. So x, you're going to see, will have 3 different restrictions. 2 from the ones that we flipped, and then 1 from here, but because we didn't have to flip that, but it was still there. So anyways, once you flip it, you have 7x plus 21 at the top, and the way you would factor that, greatest common factor of 7, so that would give you this, and 4x, break it down like this, and then you just go ahead and cross everything out that you can. So we have a 2 here that crosses out with the 2 here. Your x plus 3 from this factored 7x plus 21 crosses out with the x plus 3 here from this x squared minus 9. And yeah, you are left with this after you're done crossing everything out. And so what's been done here is we've distributed each number into their respective parentheses that they're with. and that is your final answer, of course, with your restrictions stated. So that is really the simple basic stuff about this. The only thing that's going to get harder is the expressions that you have to factor down, and of course your factor flowchart is the way to do that. You just memorize that factor flowchart, just be able to recognize when you need to do what, and you'll be all set with this unit. Now, there is another thing to note: complex fractions. When it's given to you like this, you can see here that you have 4 over x plus 2 over 3 over x plus 2. So this may seem really complicated, but all you're doing, you just gotta break it up. So take your first original fraction here, and this again is the division sign in the middle, so you're just gonna put that there, and take your bottom fraction like that. Now you have a normal looking equation, and you just go ahead and do the keep, change, flip method and solve as normal. Same thing here. It's just gonna look really funky, but you just gotta be doing the same thing, and it's the same thing repeated. What I have here is a worksheet for practice. This is simplifying rational expressions. This is pretty much all division, but it's not really too difficult problems. So you can go ahead and take a screenshot of this. Here's the top section, and here's those. And the answers are here. If you would like these answers, you can also go ahead and take a screenshot of this. Remember, there's not just one way to solve these problems. If you have a way that's easier for your head, then that's good. But in certain situations, you do just want to make it easier for yourself. Like for here, calculate the denominator first, because these can be a little difficult at times to sort through, although it is kind of the same process. And that would be our first video on Algebra 2, the introductions and everything you need to get started on this unit, simplifying rational expressions, multiplying and dividing. We did here, and just simplifying them in general. Next video will probably be regarding adding and subtracting them, and then we'll take it from there. I'll also probably be covering the box method of factoring in the next video as well. And yeah, that's that. Thanks for watching. If you have any questions, leave them in the comments, and don't forget to subscribe, hit the bell for new videos, and I'll see you in the next one.